that the Internet Society itself has actually got a position in this debate and has expressed it in a couple of venues, including an article that has my name on it. But I won't be talking about that this morning, as my role here is to provide factual background in terms of how some of the technical underpinnings actually work. At least I won't express it during my remarks here. We'll see what happens after 1 o'clock. Okay, so the DNS, the purpose of the DNS is to allow you, the common user of the internet, to be able to reach services, whether it's web services, mail services, other activities, games, for instance, without having to remember long number addresses, or soon to be even longer number and letter addresses with IPv6, but rather to express things in terms of domain names. So in order to be able to do that, there needs to be an infrastructure behind translating what you type in or when you cut and paste as a name, like www.thinkingcat.com, into an actual IP address so that the server you're trying to connect to can be found on the internet. So that's what the DNS does, and it does it through a series of background lookups that happen faster than you can imagine, because it's no longer the worldwide wait. Things are actually pretty quick these days. This is actually an animated slide, so I don't know if it'd be easier if I'll just go through and, all right, do this. All right, so general setup. Bottom left, there's you, the user, sitting at your computer. And then there are a number of other servers that are out in the internet somewhere that are participating in providing your answer when you ask, what is the IP address for www.isoc.org? Yeah, I can.
Through you.
Yeah, I realize that, but I'm not sure how we're going to get through the animation.
If I push it.
Yeah, it's.
Just go like
this. All right, so you ask. So your iterating caching resolver, and I'll tell you where that is in a moment, then asks for, goes to the root servers, of which there are 13 in the world, scattered across the globe, and asks the root server, so what's the IP address for this domain? Next. It sends back the list of name servers for that domain, and that's great. So it follows up for isoc.org. Note that this is not www.isoc.org, but just .isoc.org. Goes and asks the name server it's given, says, all right, so what's the IP address for this domain that I asked you for? And it doesn't actually give an answer either. It sends back some information about the name servers for isoc.org. Next. So that goes off to this ns1.yyz1.affiliates-nst.info, which actually does provide an answer to the question, what is the IP address for www.isoc.org? Next. Which the iterative caching resolver finally actually gives back to you, your computer. Next. And your computer then uses that and the HTTP protocol to attach to the World Wide Web server of isoc.org, and everybody's happy. So that's an awful lot of stuff that happens, and it happens indeed from the instant that you type a URL or cut and paste the URL or click a link in your browser. That's what's actually going on in the world. Next slide, please. And in the world, indeed, because all of these pieces are operated by different people, different entities. It's important to note that the DNS, like so much of the internet's infrastructure, is operated collaboratively. The internet is an inter-network. It's a bunch of networks that come together and hook up through open standards protocols in order to form the globe-spanning network. And the DNS is an important collaborative infrastructure that is operated to support it. So I've suggested in this scenario that your iterative caching resolver is operated by your ISP. In most cases, this is true. Your ISP, your school, your enterprise. The root server operators, there are 13 of them in the world. The GTLD operator here, it could be a ccTLD operator, .com, .org, .net, and then all the CCs like .us, .ca, .br, all of those are operated by different organizations, and they're all willing to respond to your requests, which is kind of interesting when you think about it. If you go to a website in some other country, that their national infrastructure is responding to you. And then the domain registrant is responsible for the name servers that hold the data, telling you where to go, what is the IP address that you need to connect to in order to get to the World Wide Web site. In our case, it happens that our registrar is actually operating our name server infrastructure. In other cases, like thinkingcat.com, the owner of the domain, the registrant, actually may be running the name server. So that is a detail that is not actually obvious to you when you click on a link. It should never, in fact, become obvious to you. But all of these things are important to the flexibility of management of this huge international infrastructure. Next slide, please. I don't really want to say a lot about this other than to say there are a lot of possible vulnerabilities in this huge international infrastructure. There are a lot of places where third parties can step in and start spoofing things. Data can get corrupted, and you in fact could, in theory, be sent off to a wrong website because of some action in the middle here. And as I said, I really don't want to get into this in detail, but I do want to emphasize that because there are known vulnerabilities, because the DNS was designed in the days when the internet was largely a research network and everybody was focused on collaboration, not criminality, the effort is now on focusing on how to deal with these vulnerabilities and secure more parts of the DNS, which leads us to, next slide please, DNSSEC, securing DNS, which is a specific tool that addresses some of the vulnerabilities in DNS, and specifically what it does is for the zone file, this is the information that you, the registrant, provide to say, when you get asked about www.isoc.org, answer with this IP address, signs that, basically ties it up and says, you can verify that in fact the information that you are getting is what I, the registrant of www.isoc.org, I, the registrant of isoc.org, wanted you to get. Whatever else is going on in this soup, you can be sure that this is what I wanted you to get. Next slide, please. And this may have transitions to step through. Yeah, this has a few steps. Yeah, there, good. So then, in that, what actually happens with seizure? So when domains are seized, the typical terminology that we use today is when the government shows up at the office of the TLD operator and says, yea, verily, we have the right to cause you to remove or adjust this registration in your database. And what happens then in this case is instead of, when you ask for the domain name, www.isoc.org, you get back not something that isoc.org provided, but something that the Department of Homeland Security provided, get their IP address, that gets passed back to you, so that when you connect to what you think is www.isoc.org, you get a web page operated by ICE, which is of the Department of Homeland Security. And if you want to try that out for yourself, rojadirecta.org, rojadirecta.org, will show you what they show you for that domain name. So that's what seizure is, basically saying, going to the registry and saying, we're plucking this name out of your database, and here you can put this one in instead. Next, please. So what is filtering? So again, I go to my ISP and I say, so what's the IP address for www.isoc.org? And it says, dunno, no such thing. NX domain is no such domain. Now, obviously this isn't true because the rest of the world is as we said it, but for whatever reason, the ISP has been directed to respond with, I'm not allowing you access to www.isoc.org. May also respond like the ICE case, may give you a different answer, but the long and the short is, it cuts out all the other steps and basically says, there you go. Next slide, please. So how do you get around that? Well, you don't use your ISP's name server. You use some other name server out in the wild and I can name a few. And it's like the iterating caching server at your ISP would still respond with an X domain, but you said, I'm bypassing that, I'm going off to some other server. In fact, that other server could be you. You could run all of this on your own server. So there may actually be legitimate reasons for you to do this, I will observe. If you have the same ISP as I do, you may be tired of the fact that they can't seem to keep their name servers up, so you may prefer to use a public domain server, which is, to my way of thinking, a reasonable, at least not maliciously intended reason to use a different public name server. In which case, all of this effort to control what your ISP shows you fails. Okay, next slide, please. If there is one, no, there isn't. The one thing that I wanted to comment on and didn't quite get to in the filtering question is, remember what I said about the DNSSEC signing the content of the zone file so that you could be sure that you got what I intended you to get for www.isoc.org. One of the issues with filtering is there is no way that an ISP can give you an answer like an X domain or some other IP address without you being able to detect that this has been tampered with, because that's what DNSSEC does. There's no way for the ISP to, re-sign what you've got for www.isoc.org, so it will come across as being something bogus. So at that point, your choices are to say it's bogus and understand that things have failed, or to say, why am I getting so many bogus answers? This DNSSEC stuff doesn't work, I'm going to stop using it.